Hello there, and welcome to Cosmic Sleep Stories. I'm so glad you found your way here tonight. Maybe you've looked up at the Milky Way on a clear night and wondered what secrets it holds. Or perhaps you're simply seeking a peaceful place to rest your mind. Either way, you're exactly where you need to be. You can rest now. Tonight, you have nothing to do but let go. Let your breathing slow, steady as the rotation of our galaxy itself. Let your body relax, sinking into comfort like a star settling into its orbit. Let your mind drift outward, beyond Earth, beyond the solar system, into the vast spiral of the Milky Way where 200 billion stars shine in the darkness. Over the next hour and more, we'll take a gentle journey together through our cosmic home. We'll travel through spiral arms filled with newborn stars. We'll visit ancient globular clusters orbiting the galactic center. We'll explore nebulae where stars are being born right now. We'll measure the vast distances that separate one wonder from another. We'll discover the architecture of our galaxy, its structure and motion, its past and its future. Some facts will captivate you. Others will simply wash over you like starlight, leaving only soft impressions as you drift towards sleep. And that's perfectly fine. There's no need to remember every detail. Just let yourself be carried by the wonder of it all, by the vastness and beauty of the galaxy that is our home. The Milky Way isn't just a band of light across the sky. It's a vast cosmic city containing everything we've ever known, every star we've ever seen, every planet that might harbor life. And tonight, we'll explore it together, slowly, gently, as you drift towards sleep. And before we begin our journey through the stars, if these quiet cosmic explorations help you unwind at the end of your day, consider subscribing to Cosmic Sleep Stories. It helps others find this peaceful corner of the universe, one sleepy soul at a time. Now, close your eyes if you'd like. Breathe slowly, feeling yourself held by Earth even as your mind prepares to wander among the stars. And let's begin our gentle journey through the Milky Way. The Milky Way galaxy is home. Not just Earth, not just the solar system, but the entire galaxy is our cosmic neighborhood, the vast collection of stars and gas and dust and dark matter that we belong to. When you look up at the night sky, every star you see with your naked eye is part of the Milky Way, your neighbor in this island universe floating through the cosmos. Our galaxy is a barred spiral galaxy, shaped like a flat disk with a central bulge and spiral arms winding outward from the center. Imagine a fried egg, but instead of egg white, imagine spiral arms of stars curving gracefully through space. That's roughly the shape of our galaxy, though the reality is far more complex and beautiful. The Milky Way is approximately 100,000 light-years across. A light-year is the distance light travels in 1 year, about 9.5 trillion kilometers. So the galaxy is 950,000 trillion kilometers from one edge to the other. These numbers are so large they become almost meaningless to human comprehension, but they give you a sense of the scale we're working with. The galaxy is relatively thin compared to its width, only about 1,000 light-years thick in the disk where most stars live. This makes the Milky Way quite flat, like a cosmic pancake, though the central bulge is thicker, about 10,000 light-years from top to bottom. Our solar system sits about 26,000 light-years from the galactic center, roughly halfway out toward the edge. We're in a relatively quiet suburban region of the galaxy, not in the crowded, chaotic center and not in the lonely outer reaches, but in a comfortable middle ground where stars are spaced reasonably far apart. The Sun orbits the galactic center at a speed of about 220 kilometers per second, fast enough to circle Earth 5 times in 1 minute. Despite this tremendous speed, it takes approximately 230 million years to complete one orbit around the galaxy. This period is sometimes called a cosmic year or galactic year. Think about that for a moment. The last time the Sun was in this exact position in its orbit, dinosaurs were just beginning to emerge on Earth. When it completes its current orbit, Earth will be unimaginably different, transformed by time and evolution in ways we can't predict. The Milky Way contains between 200 and 400 billion stars. That's 200 to 400,000 million stars, each one a sun, many of them with their own planets, their own solar systems, their own potential for harboring life. The exact number is uncertain because we can't see all of them, many hidden by dust or simply too dim to detect. But even if we use the lower estimate, 200 billion stars. That's more stars in the Milky Way than there are people on Earth times about 25. If every person on Earth represented a star, you'd need 25 Earths full of people to match the number of stars in just our one galaxy. And the Milky Way is just one galaxy among hundreds of billions in the observable universe. We're part of something incomprehensibly vast, a small corner of one galaxy among countless others, yet still connected to it all, made of atoms that came from dying stars, following the same physical laws that govern the entire cosmos. As you rest now, let yourself feel that connection. You're not separate from the galaxy, but part of it, made of its substance, following its motion through space. Temporary but real, brief but meaningful, a small pattern of consciousness emerging from the vast patterns of matter and energy that make up the Milky Way. Let your breathing match the slow rhythm of galactic rotation, deep and steady, eternal and peaceful. Let your body relax completely, held by Earth's gravity, which is itself part of the Milky Way's gravitational field, the force that holds everything together, that keeps stars in their orbits and galaxies in their shapes. The center of the Milky Way is a place of extremes. Here, 26,000 light-years from Earth, stars are packed much more densely than in our neighborhood. If you could stand on a planet near the galactic center, your night sky would contain thousands of stars brighter than Venus, so many that you could read by starlight, so many that you'd barely be able to see the darkness between them. At the very heart of the galaxy sits Sagittarius A star, a supermassive black hole containing about 4 million times the mass of our Sun. Despite this enormous mass, it's remarkably quiet, not currently feeding on much material, just sitting peacefully at the gravitational center, around which everything else orbits. The black hole itself is hidden from our view by dense clouds of gas and dust, but we can observe its effects on nearby stars. Astronomers have tracked dozens of stars orbiting Sagittarius A star, some completing their orbits in just 16 years, reaching speeds of up to 7,650 kilometers per second, about 2.5% the speed of light. These orbits prove that something incredibly massive and compact sits at the center. Only a black hole fits the observations. In 2022, astronomers even captured an image of the black hole's event horizon using a global network of radio telescopes, showing a glowing ring of hot gas surrounding a dark center, exactly as theory predicted. Surrounding the central black hole is the galactic bulge, a roughly spherical collection of old stars, about 10,000 light-years across. These stars are ancient, formed in the early days of the galaxy's history, and they orbit in random directions rather than following the organized rotation of the galactic disk. The bulge is yellowish in color because it contains mostly old, cool stars. Young, hot blue stars are rare here. Most of the star formation in the galaxy happens farther out in the disk, where there's more gas and dust available to make new stars. Beyond the bulge, the galactic disk spreads outward, a vast flat collection of stars, gas, and dust organized into beautiful spiral arms. This is where most of the galaxy's mass resides, where most of the stars live, where we find our solar system and all the familiar constellations. The disk rotates, but not like a solid object. Different parts rotate at different speeds. Stars closer to the center orbit faster, stars farther out orbit slower. This differential rotation causes the spiral arms, creating waves of density that sweep through the disk, triggering star formation wherever they pass. Imagine a traffic jam on a circular highway. Cars slow down in the jam, pile up, then speed up again once they're through. The jam itself doesn't move with any individual car, but persists as a pattern, moving slowly around the highway. The spiral arms are like that, density waves that persist even as individual stars move through them. The Milky Way has several major spiral arms curving through the disk. The Sagittarius arm, the Scutum Centaurus arm, the Norma arm, and the Perseus arm are the most prominent. Our solar system sits on a small spur called the Orion spur or local arm, a minor arm between the larger Sagittarius and Perseus arms. These spiral arms aren't solid structures, but regions where stars and gas are more concentrated. Stars drift in and out of the arms over millions of years as they orbit the galactic center. When they're in an arm, they're more likely to encounter gas clouds that might disturb their orbits or trigger new star formation. The spiral arms are where most of the galaxy's star formation occurs. They contain vast clouds of gas and dust, the raw material for making stars, concentrated by the density waves that create the arms. When these clouds collapse, they form new stars, often in large groups called star clusters. Some of these star-forming regions are visible from Earth even with the naked eye. The Orion Nebula, that fuzzy patch in Orion's sword, is a stellar nursery about 1,350 light-years away. The Lagoon Nebula, the Eagle Nebula with its famous pillars of creation, the Carina Nebula where massive stars are being born, all of these are part of the Milky Way's ongoing cycle of star formation. In these nebulae, we're watching creation happen in real time. Clouds of hydrogen gas, the most common element in the universe, slowly collapse under their own gravity, growing denser and hotter until nuclear fusion ignites in their cores. At that moment, a star is born, beginning a life that might last millions or billions of years. The largest nebulae can form hundreds or thousands of stars at once. These stars are born together, siblings sharing the same chemical composition, the same age, the same general location. Over time, they'll drift apart, dispersed by their own motions and by interactions with passing gas clouds. But for a while, they form star clusters that move through the galaxy together. Open star clusters are loose groups of young stars, still relatively close to their birthplace. The Pleiades, that tight knot of bright stars visible in winter, is an open cluster about 100 million years old, containing about 1,000 stars. It's close enough and bright enough that even ancient peoples recognized it as something special. These clusters gradually disperse over hundreds of millions of years as gravitational interactions with other stars and gas clouds pull them apart. Eventually, the stars become indistinguishable from the general field of stars in the galaxy, their common origin forgotten except in their similar chemical compositions. As you drift now, imagine yourself floating through one of these spiral arms, surrounded by newborn stars, shining blue and brilliant, by glowing clouds of gas lit by their ultraviolet light, by the soft darkness of dust clouds where future stars are condensing. Let yourself be carried by the spiral wave, moving slowly through the galactic disk, witnessing the ongoing creation of stars. There's something deeply peaceful about this scale of motion. Everything moves, but so slowly from our perspective that it seems almost still. Stars drift in their orbits over millions of years. Spiral arms rotate over tens of millions of years. The galaxy itself turns majestically, following the same patterns it's followed for billions of years, following the laws of gravity and motion that govern all things. You don't need to understand the physics. You don't need to calculate orbital mechanics or measure density waves. You can simply appreciate the beauty, the vastness, the slow dance of stars and gas moving through space, creating and destroying and creating again in an endless cycle that's been going on since the galaxy formed and will continue long after you're gone. Breathe slowly. Feel your body becoming heavier, settling deeper into rest. And let yourself be part of the galactic motion, orbiting around the center along with the Sun and Earth, moving through space at 220 kilometers per second, yet feeling perfectly still, perfectly at rest, because everything around you is moving the same way. Between the spiral arms, in what astronomers call the interarm regions, the galaxy is quieter. Fewer stars are being born. The density of gas is lower. The light is dimmer, dominated by the steady glow of older stars rather than the brilliant blue of young, massive stars. Our solar system spends most of its time in these interarm regions, only occasionally passing through the spiral arms as it orbits. This might be fortunate for life on Earth. The spiral arms contain more supernovas, more cosmic rays, more gravitational disturbances that could perturb comets from the outer solar system and send them falling inward toward the planets. By living in a relatively quiet region, we're protected from some of the galaxy's more violent phenomena. We're far enough from the chaotic center, but not so far out that we're in the empty outer regions. We're in a kind of galactic Goldilocks zone, not too dangerous, not too isolated, just right for a planet that harbors life. The Milky Way contains more than just stars. Between the stars lies the interstellar medium, a thin but extensive collection of gas and dust that fills the space between star systems. This medium is mostly hydrogen, the simplest and most common element, along with smaller amounts of helium and trace amounts of heavier elements. The interstellar medium is incredibly thin by Earth standards. In the densest molecular clouds, there might be 10,000 particles per cubic centimeter. That sounds like a lot until you realize that Earth's atmosphere at sea level contains about 10 to the power of 19 particles per cubic centimeter. The dense clouds of space are better vacuums than any we can create in laboratories on Earth. Yet despite this extreme thinness, the interstellar medium is important. It's the raw material for making new stars and planets. It's enriched with heavy elements from dying stars, making each new generation of stars slightly more metal-rich than the previous generation. And it's where complex chemistry happens, where molecules form that might eventually contribute to the emergence of life. Astronomers have detected over 200 different molecules in the interstellar medium, from simple two-atom molecules like hydrogen and carbon monoxide to complex organic molecules containing dozens of atoms. Some of these molecules are the building blocks of life, amino acids and sugars and other organic compounds, floating in the space between stars. This suggests that the chemistry needed for life is common in the galaxy, that the basic ingredients are widespread, forming naturally through cosmic processes. Life on Earth might not be a unique accident, but an expected consequence of chemistry and physics operating over billions of years in a galaxy rich with the necessary elements. The Milky Way also contains dust, tiny solid particles of carbon, silicon, iron, and other elements. These dust grains are small, typically less than a micron across, smaller than bacteria, but they're important. They absorb and scatter light, creating the dark lanes visible in images of the Milky Way, blocking our view of distant stars. Dust is also where molecules form in space. The surface of dust grains provides a place for atoms to meet and stick together, building up complex molecules that would be much harder to form in the near vacuum of space. Over time, these dust grains get incorporated into new stars and planets, bringing their coating of organic molecules with them. When you look at the Milky Way on a dark night, the dark patches aren't empty space. They're clouds of dust, blocking the light of stars behind them, creating silhouettes against the background glow. The Great Rift, that dark band running through the summer Milky Way, is a chain of these dust clouds, thousands of light years long, obscuring the bright center of the galaxy from our view. Without this dust, we'd see much more of the galaxy. The center would blaze brilliantly, the spiral arms would be clearly visible, the structure of the Milky Way would be obvious to anyone who looked up. But the dust hides much from us, forcing us to use radio waves and infrared light to peer through it and see what lies beyond. This obscuration makes studying our own galaxy surprisingly difficult. We're inside it, surrounded by stars and dust, unable to step outside and see the whole structure clearly. It's like trying to understand the layout of a city while standing on a street corner. You can see nearby buildings clearly, but the overall structure is hidden. Yet through patient observation, through mapping star positions and movements, through studying the light from distant galaxies and seeing how it's absorbed by intervening dust, through using multiple wavelengths of light that penetrate dust more easily, we've gradually built up a picture of the Milky Way structure. We know its size, its shape, the locations of its spiral arms, the distribution of its matter. As you rest now, think about the dust between stars, the thin veil that obscures but also creates, that blocks light but also enables chemistry, that seems like emptiness but is actually the womb from which stars and planets are born. Nothing in the galaxy is truly empty. Even the spaces between stars contain material, thin but real, contributing to the ongoing cycle of creation and destruction. Let yourself be like that interstellar medium, diffuse and relaxed, spread out and at rest, not concentrated or tense, but gently dispersed, comfortable in the vastness, at peace in the emptiness. Let your thoughts become thin like the gas between stars, present but not pressing, there but not overwhelming, just existing quietly in the space of your mind. Breathe deeply. Let tension dissipate like a cloud of gas expanding in space. And let yourself drift in the gentle darkness, not the darkness of absence, but the darkness of potential, the same darkness that fills the galaxy, comfortable and peaceful and full of possibilities. Surrounding the galactic disk is a vast, roughly spherical region called the galactic halo. This halo contains very little gas or dust, almost no ongoing star formation, but it does contain stars, ancient stars in globular clusters orbiting the galaxy like bees around a hive. Globular clusters are tight balls of stars, typically containing hundreds of thousands or even millions of stars packed into a region only 100 or 200 light-years across. These stars are old, among the oldest in the galaxy, formed in the early days over 10 billion years ago when the Milky Way was still coming together. The Milky Way has about 150 known globular clusters, though there are probably more hidden behind dust or simply too faint to detect. These clusters orbit the galactic center in eccentric orbits, plunging through the disk, rising high above it, then falling back through again, taking millions of years to complete each orbit. The stars in globular clusters are densely packed compared to the solar neighborhood. In the center of a dense globular cluster, stars might be separated by only 0.1 light-years or less. If you lived on a planet in such a cluster, your night sky would contain hundreds of stars brighter than Sirius, the brightest star visible from Earth. But you probably wouldn't live in a globular cluster. The old stars there are metal-poor, formed from gas that hadn't been enriched by many previous generations of stars. They're mostly hydrogen and helium, with very little of the heavier elements needed to form rocky planets like Earth. Globular clusters might not have many planets, and those they do have would be very different from Earth. The halo also contains individual stars, not in clusters, called halo stars or population 2 stars. These stars follow highly elliptical orbits that take them far above and below the galactic disk. They're old, metal-poor, moving at high velocities relative to the Sun, passing through our neighborhood quickly on their long, looping orbits. The halo extends far beyond the visible disk, possibly as far as 300,000 light-years or more. But this extended halo isn't made of stars or gas. It's made of dark matter, the mysterious substance that makes up most of the galaxy's mass, but doesn't emit or absorb light. Dark matter is one of the great mysteries of modern astronomy. We can't see it directly, but we know it exists because of its gravitational effects. The outer parts of galaxies rotate faster than they should based on the visible matter alone. Something invisible is providing extra gravity, and we call that something dark matter. In the Milky Way, dark matter probably outweighs all the stars, gas, and dust combined by a factor of about 10 to 1. The galaxy is mostly dark matter, with normal matter being almost an afterthought, a thin frosting of visible material on top of a vast, invisible substrate. What is dark matter? We don't know. It might be exotic particles that don't interact with light. It might be primordial black holes. It might be something else entirely that we haven't imagined yet. Experiments are searching for it, trying to detect its particles or measure its effects directly. But so far, dark matter remains one of the universe's deepest mysteries. Yet this invisible material is crucial to the galaxy's structure. It's the dark matter's gravity that holds the Milky Way together, that determines how fast stars orbit, that influences how the galaxy formed and evolved over billions of years. Visible matter follows paths carved by dark matter's gravitational field. As you drift deeper now, let yourself appreciate the mystery. The universe contains things we don't understand, phenomena we can measure but not explain, forces we know exist but can't directly detect. This isn't a failure of science, but a reminder of how much remains to be discovered. You don't need to understand dark matter to rest peacefully. You don't need to solve cosmic mysteries to sleep. You can simply acknowledge the unknown, accept it, find comfort in knowing that the universe is larger and stranger than we currently comprehend, that there are always more questions to ask, more wonders to uncover. Let the unknown be comforting rather than threatening. Let the darkness between stars be peaceful rather than frightening. Let yourself sink into the soft darkness around you, the familiar darkness of night and sleep, knowing that even this small darkness is connected to the vast darkness of space, to the dark matter that fills the galaxy, to the comfortable mystery that surrounds us. Breathe slowly. Feel yourself dissolving into rest, into the peaceful unknown of sleep where consciousness fades and only darkness remains, warm and gentle and safe. The Milky Way hasn't always looked the way it does now. Galaxies evolve, changing over billions of years as they form stars, merge with other galaxies, interact gravitationally with their neighbors. Our galaxy has a history, a story of formation and transformation that we're slowly piecing together. The Milky Way probably formed about 13 billion years ago, less than a billion years after the Big Bang, when the universe was still young. It started as a large cloud of hydrogen and helium gas, slowly collapsing under its own gravity, fragmenting into smaller clouds that became the first stars. Those first stars were massive and short-lived, burning brilliantly for only a few million years before exploding as supernovas. These explosions enriched the surrounding gas with heavy elements, carbon and oxygen and iron, making the next generation of stars slightly more metal-rich. The galaxy's central bulge probably formed first, the densest region collapsing most quickly. The disk came later, forming as gas fell inward from the halo, conserving its angular momentum, flattening into a spinning disk. This process took billions of years, with the galaxy's structure gradually emerging from the initial chaos. The Milky Way has consumed other galaxies over its lifetime. We can see the remains of these mergers in streams of stars scattered through the halo, tidally disrupted satellites, whose stars are now spread along their former orbits. The Sagittarius dwarf galaxy is currently being torn apart by the Milky Way's gravity, its stars stripped away and added to our galaxy. The Magellanic Clouds, those two fuzzy patches visible from the southern hemisphere, are small galaxies orbiting the Milky Way. They're being slowly consumed, losing gas to our galaxy's gravitational pull, creating the Magellanic Stream, a long arc of hydrogen stretching across the sky. In about 4 billion years, the Milky Way will collide with the Andromeda Galaxy, our nearest large galactic neighbor. This collision will take billions of years to complete, with the two galaxies passing through each other multiple times before finally merging into a single, larger galaxy. Despite the name collision, individual stars almost certainly won't hit each other. The distances between stars are so vast that they'll mostly pass by like ships in the night. But the gas clouds will collide, triggering enormous bursts of star formation, and the overall structure of both galaxies will be completely transformed. The night sky will change dramatically during this collision. Andromeda will grow larger and larger as it approaches, eventually stretching across the sky. New stars will blaze to life by the millions. The spiral structure of both galaxies will be disrupted, eventually merging into a single elliptical galaxy. By the time the merger is complete, the Sun will be an old, dying star. Earth, if it still exists, will be a very different place. The merger won't directly affect the solar system much. We'll just find ourselves in a different galaxy, with a different structure and a different name, possibly something like Milkomeda, a blend of Milky Way and Andromeda. But that's billions of years in the future. For now, the Milky Way continues its stately rotation, its stars following their orbits, its spiral arms turning slowly like a cosmic clock, marking the passage of galactic time. As you rest, think about deep time, about changes that unfold over billions of years, about processes so slow they're invisible to individual lives, but which shape everything over cosmic timescales. The galaxy you see tonight is different from the galaxy that existed when dinosaurs walked Earth, and different still from the galaxy that will exist billions of years hence. Yet from your perspective, from human perspective, the galaxy is eternal, unchanging, the same stars in the same positions, night after night, year after year, millennium after millennium. The changes are too slow to perceive directly, too gradual to measure in a single lifetime. This is comforting in a way. The galaxy provides a sense of permanence, of stability, a cosmic backdrop against which human dramas play out. The stars will still be there tomorrow, and the day after, and 1,000 years from now, following the same orbits, shining the same light, patient and eternal from our brief perspective. Let that permanence support you as you drift toward sleep. The galaxy was here before you were born and will remain long after you're gone. The stars don't care about your problems, your worries, your fears. They simply exist, shining steadily, following their paths through space, indifferent to human concerns in a way that's oddly comforting. You don't need to be important to the galaxy. You don't need to make a cosmic difference. You can simply exist, briefly, peacefully, as a temporary pattern of consciousness, experiencing the universe for a few decades before dissolving back into the atoms that made you, which will eventually become part of other stars, other planets, other possibilities. Breathe deeply. Let the cosmic perspective ease your daily concerns. And let yourself sleep peacefully, held by a planet orbiting a star in a galaxy that continues turning regardless of whether you're awake or asleep, conscious or dreaming, worried or at peace. The Milky Way is full of worlds, planets of every description orbiting stars throughout the galaxy. Astronomers have discovered thousands of exoplanets, planets around other stars, and every discovery suggests that planets are common, that most stars probably have them, that our solar system is typical rather than unique. Some of these planets are gas giants like Jupiter, massive worlds of hydrogen and helium with no solid surface. Some are super-Earths, rocky planets larger than Earth but smaller than Neptune. Some are hot Jupiters, massive planets orbiting very close to their stars, heated to thousands of degrees. Some are rogue planets, ejected from their birth systems, wandering through the galaxy alone in the darkness. Among these billions of planets, how many might harbor life? We don't know, but the basic requirements seem common. Liquid water, complex chemistry, energy from a star or from the planet's interior. These ingredients exist throughout the galaxy. Life might be rare, or it might be common. We simply don't have enough data yet. The search for life beyond Earth is one of humanity's great quests. We've sent messages into space, hoping to contact intelligent civilizations. We've listened for radio signals from other worlds. We've studied the atmospheres of exoplanets, looking for biosignatures, chemical signs that living processes might be altering a planet's air. So far, we've found nothing definitive. No alien transmissions, no unambiguous signs of life. This could mean life is rare, or it could mean we haven't looked long enough or in the right places. The galaxy is vast, and we've only just begun to search it. But even if we're alone, or even if intelligent life is incredibly rare, the galaxy is still full of wonders. Every star is interesting. Every planet tells a story about formation and evolution. Every nebula showcases the beauty of physics operating at cosmic scales. The Milky Way doesn't need aliens to be magnificent. Some of the most beautiful objects in the galaxy are planetary nebulae, glowing shells of gas ejected by dying stars. When a star like the Sun reaches the end of its life, it swells into a red giant, then sheds its outer layers, creating a luminous cloud that slowly expands into space. The Ring Nebula, the Cat's Eye Nebula, the Helix Nebula, these are planetary nebulae, and they're spectacular in images, showing intricate structures, multiple shells, jets and knots and filaments of glowing gas. They're among the most beautiful objects in the galaxy, each one unique, each one revealing details about stellar death and the recycling of matter. These nebulae fade over tens of thousands of years as the gas disperses, eventually becoming invisible, mixing with the interstellar medium, contributing to the next generation of stars. The atoms in these nebulae will eventually find their way into new stars, new planets, perhaps even new life, continuing the cosmic cycle. Supernova remnants are even more dramatic, the expanding shells of gas from stars that died violently. The Crab Nebula is a supernova remnant, the scattered debris from a star that exploded in 1054 CE, visible from Earth as a bright new star that appeared suddenly in the sky. The Vela supernova remnant, the Cygnus loop, Cassiopeia A, these are the blast waves from ancient supernovas, still expanding thousands of years after the explosions that created them, still visible as glowing shells of hot gas spreading through space at thousands of kilometers per second. These remnants are forges where heavy elements are born, where shock waves compress and heat gas, where cosmic rays are accelerated to nearly the speed of light. They're violent, energetic, beautiful in their own way, showcasing the extreme end of stellar evolution. As you drift now, let these images wash over you. Glowing nebulae, expanding supernova shells, stellar nurseries where new stars are being born, planetary nebulae, where dying stars create their final works of art. The galaxy is full of beauty at every scale, from the largest structures to the smallest details. You don't need to see these objects directly to appreciate them. You can imagine them, colorful and bright against the darkness of space, each one a masterpiece of natural processes, each one following the laws of physics, but creating outcomes of stunning complexity and beauty. Let that beauty fill your mind as you approach sleep. Let the colors of emission nebulae, red from hydrogen, green from oxygen, blue from hot stars, let these colors paint your inner vision. Let the spiral arms of the galaxy turn slowly in your imagination. Let yourself float among the stars, peaceful and safe, a consciousness drifting through wonders. Breathe slowly. Feel your body completely at rest. And let yourself merge with the darkness, becoming part of the cosmic night, joining the vast silence between stars, finding peace in the great empty spaces that fill most of the galaxy. The Milky Way's rotation reveals something fascinating about its structure. Stars in the outer regions of galaxies should orbit more slowly than stars near the center, just as outer planets in our solar system orbit more slowly than inner planets. But they don't. The rotation curve of the Milky Way stays flat, with outer stars moving just as fast as expected for inner stars. This is one of the key pieces of evidence for dark matter. The visible matter in the galaxy can't account for this rotation pattern. There must be additional mass, invisible mass, extending far beyond the visible disk, providing the extra gravity needed to keep outer stars moving so fast. The dark matter halo extends hundreds of thousands of light years, far beyond the stars and gas, an invisible scaffolding that holds the galaxy together. This halo might contain 10 times more mass than all the visible matter combined, making the Milky Way mostly a dark matter structure with a thin frosting of visible material. Understanding the distribution of this dark matter helps us understand how the galaxy formed and evolved. Computer simulations show that dark matter halos form first, collapsing from the early universe, and then normal matter falls into these halos, creating the visible galaxies we see today. The Milky Way's magnetic field is another invisible component of galactic structure. This field is weak by everyday standards, about 1,000,000 times weaker than a refrigerator magnet, but it extends throughout the galactic disk, influencing charged particles and the interstellar medium. Cosmic rays, high-energy particles zipping through space at nearly the speed of light, are guided by this magnetic field. They spiral along field lines, trapped in the galaxy, unable to escape easily. This keeps cosmic rays distributed throughout the disk, where they affect star formation and the evolution of the interstellar medium. The galactic magnetic field also shapes the structures we see in nebulae and supernova remnants. Field lines can channel gas flows, creating filaments and sheets, organizing the chaos of exploding stars into structured patterns. Looking at these patterns, we can infer the direction and strength of the magnetic field even though we can't see it directly. Measuring the Milky Way's properties requires clever techniques since we're inside it. We use parallax to measure distances to nearby stars, watching how they appear to shift position as Earth orbits the Sun. We use Cepheid variables, pulsating stars whose brightness variations are related to their intrinsic luminosity, as standard candles to measure distances to star clusters. We use spectroscopy to measure velocities, watching how light is Doppler shifted by motion toward or away from us. We use infrared observations to peer through dust and see the galactic center. We use radio observations to map hydrogen clouds and trace the spiral arms. Every method has limitations and uncertainties, but by combining many different observations, by cross-checking results, by building models and testing them against data, we've gradually built up a comprehensive picture of the Milky Way structure, composition, and motion. We know its size, its mass, its rotation rate. We know the locations of its spiral arms and the properties of its central black hole. We know how fast it's moving through space relative to the cosmic microwave background. We know its age and its chemical composition and its likely future. This knowledge is a triumph of human ingenuity, of curiosity driving us to understand our place in the cosmos. We live inside the galaxy, surrounded by stars and dust, unable to step outside for a clear view, yet we've mapped it anyway, using mathematics and physics and patient observation. As you rest now, appreciate this achievement. Humans, tiny creatures on a small planet, have mapped a galaxy containing hundreds of billions of stars. We've measured distances across thousands of light years. We've traced structures that dwarf our entire solar system. We've understood, at least partially, the vast cosmic city that is our home. This is what consciousness can do, what intelligence can achieve. We can transcend our immediate surroundings, understand things far beyond our direct perception, build mental models of reality that extend from the subatomic to the cosmic. This is our gift as thinking beings, our ability to comprehend the universe that created us. Let that thought be your last conscious thought tonight. You are part of a species that can understand galaxies, that can measure the cosmos, that can look up at the Milky Way and know what it is, how it formed, where it's going. You carry that understanding with you, that connection to the cosmic whole. And now, let that understanding dissolve into sleep. Let knowledge fade into the comfortable darkness. Let consciousness release its grip on facts and structures and measurements, letting everything go, returning to the simple, peaceful state of rest. The Milky Way will continue turning while you sleep, its stars following their orbits, its spiral arms rotating slowly, its black hole sitting quietly at the center. And you can rest peacefully, knowing that you're part of it all, a brief flickering of consciousness in a galaxy that's been shining for 13 billion years and will continue for billions more. Our galaxy is part of a larger structure called the local group, a collection of about 80 galaxies bound together by gravity. The Milky Way and Andromeda are the dominant members, each attended by dozens of smaller satellite galaxies orbiting like moons. The local group itself is part of an even larger structure, the Virgo supercluster, containing thousands of galaxies spread across 110 million light-years. And the Virgo supercluster is just one of many superclusters, connected by filaments and separated by voids, creating the cosmic web, the largest structure in the universe. This web stretches across billions of light-years, with galaxies strung along filaments like beads on a string, separated by vast empty regions called voids where few galaxies exist. The Milky Way sits in one of these filaments, connected through gravity to countless other galaxies, all of them moving through space together, all of them part of the same cosmic structure. The Milky Way is moving through space at about 600 kilometers per second relative to the cosmic microwave background, the afterglow of the Big Bang. Some of this motion is due to the local group's movement toward the Virgo cluster. Some is due to the gravitational pull of an enormous concentration of mass called the Great Attractor, located about 150 million light-years away. We're all falling, in a sense, pulled by gravity toward concentrations of mass, participating in flows of galaxies on scales so vast that our entire galaxy is just a tiny particle in the current. But these motions are so slow compared to cosmic distances that they're barely noticeable, taking hundreds of millions of years to produce significant changes in position. The Milky Way's future is tied to these larger structures. We'll eventually merge with Andromeda, creating a larger galaxy. This merger might disrupt our motion through the local group, changing our trajectory. But the overall structure, the flow toward the Virgo cluster, will probably continue, carrying us along with countless other galaxies. In the far future, billions of years from now, the universe's accelerating expansion will carry distant galaxies beyond our horizon, making them invisible even in principle. The local group will become isolated, surrounded by darkness, unable to see the rest of the universe. The Milky Way and Andromeda, merged into a single galaxy, will be alone with their satellite galaxies. But that's so far in the future it's almost meaningless. For now, for the next few billion years, the Milky Way will continue as it has, a vibrant spiral galaxy, forming new stars, evolving slowly, part of the larger cosmic web that stretches across the observable universe. As you drift into the deepest stages of sleep now, let yourself feel both the smallness and the connection. You're tiny compared to the galaxy, insignificant on cosmic scales, brief in time and limited in space. And yet you're part of it all, connected through gravity and chemistry and physics to every star in the Milky Way, to every galaxy in the local group, to the entire cosmic web. Let that dual nature be comforting. You're small enough that your worries don't matter to the cosmos, yet large enough to comprehend the cosmos, to understand your place in it, to feel wonder at the vast structures that surround you. You're made of atoms forged in stars, carbon and oxygen and nitrogen created in stellar furnaces billions of years ago, scattered through space by supernovas, collected into gas clouds, condensed into the sun and Earth, eventually organized into the complex pattern that is you. In a very real sense, you are the galaxy becoming conscious of itself, matter organized so complexly that it can think about its own origins, can look up at the stars and recognize them as distant suns, can measure cosmic distances and understand galactic structures. And right now, this small piece of the galaxy that is you needs to rest, needs to sleep, needs to let consciousness fade and let the body restore itself through the natural process of sleep that evolution has refined over billions of years. So let go now. Let the Milky Way continue without your attention. Let the stars shine whether you're awake to see them or not. Let the galaxy turn, ancient and patient, while you sleep peacefully, safely held by Earth, orbiting the sun, which is orbiting the galactic center, all of it moving together through space. You've traveled far tonight, from Earth to the galactic center and back, through spiral arms and stellar nurseries, past globular clusters and supernova remnants, learning about dark matter and magnetic fields and the future collision with Andromeda. You've seen the galaxy as a whole, a vast, beautiful structure that has been your home since before you were born and will be your home until the day you die. And now it's time to rest. Time to stop thinking about cosmic scales and galactic structures. Time to simply be here, in your body, in your bed, in this moment, letting everything else fade into the background. The Milky Way will be there tomorrow night, stretching across the sky if you're somewhere dark enough to see it. That band of light, that is your galactic home seen from inside. You can look up at it and know what it is, can appreciate its beauty and its vastness, can feel connected to all the stars that make it shine. But tonight, you don't need to look up. You can close your eyes, or perhaps they're already closed, and let the gentle darkness of sleep embrace you. Let your breathing become so slow and soft that you barely notice it. Let your body sink so completely into the bed that you feel like you're floating, weightless, drifting through space. Let thoughts dissolve like clouds of gas dispersing in the interstellar medium. Let consciousness fade like a distant star disappearing below the horizon. Let everything that makes you awake and alert and thinking, let it all wind down, settle, become still and quiet and dark. You're safe here. You've always been safe here. The Milky Way has existed for 13 billion years, and throughout that vast expanse of time, it's created the conditions that allowed you to exist, protected your world from the worst cosmic hazards, provided the stable environment needed for life to evolve and flourish. And it will continue protecting you, continue providing that stable backdrop, that cosmic home, for as long as you live. You're held by more than just your bed, more than just Earth's gravity. You're held by the entire galaxy, by the gravity that binds everything together, by the long, slow processes that created you and will continue long after you're gone. So rest easy. Sleep peacefully. Let yourself be carried through the night by the turning of the Earth, which is carried by the orbit around the sun, which is carried by the rotation of the galaxy, which is carried by the expansion of the universe, all of it moving together, all of it part of one vast cosmic dance. And in the morning, you'll wake to find yourself still here, still on Earth, still orbiting the sun in the Milky Way. The galaxy will have turned a tiny amount, an imperceptible fraction of its rotation. The stars will be in almost exactly the same positions they were tonight. Everything will be familiar, stable, safe. But for now, for these next hours of darkness, let yourself disappear into sleep. Let the journey end. Let consciousness fade completely. Let there be only the soft, warm darkness of deep sleep, dreamless and peaceful, restorative and complete. Good night.